Okay, let's unpack this. You've sent over some fascinating material exploring how AI models recognize different categories, and it looks like you're trying to get a handle on why these systems sometimes nail it, sometimes completely miss.
And sometimes make these really surprising errors.
Exactly. We're about to dive deep into these specific test cases to see what they really tell us about how AI recognition works, under the hood.
Right. We have a set of specific examples here, looking at how two different AI models, let's just
Hmm.
call the Model A and Model B, reacted to various image samples.
Okay.
And these range from, easy, clear identifications to much more challenging situations.
Mm-hmm.
Stuff designed to really test the limits of what they've learned.
Right. We're looking at everything from a pretty straightforward orange identification to uh, trickier stuff like noisy images,
Mm.
mislabeled data,
Hmm.
and even subtle distinctions within a category like telling the difference between parrots and penguins. That sounds interesting.
Yeah.
So our mission today is really to pull out the crucial insights from these tests so you can properly understand the strengths and, well, where things can fall apart in AI pattern recognition.
Get ready for some aha moments, hopefully.
Definitely. So where should we jump in first?
Well, I think a logical starting point is to look at the three main ways these models responded when, analyzing something they were trained to recognize.
Okay, three ways.
The first one, as the source material details, is simply correct recognition. The AI gets it right.
And we have a perfect illustration of that right at the start, don't we? The orange example.
Exactly.
When shown an image of an orange, both Model A and Model B correctly identified it. And with really high confidence scores too, like 99.8% for A and 98.1% for B.
Pretty high, yeah.
And this seemingly simple case, it already highlights a crucial insight. Even with maybe variations in the data used to train them, AI models can robustly learn fundamental concepts.
But as we'll see, this robustness doesn't always extend to all categories.
Ah,
And what's fascinating here is that even though both models were accurate, the information notes their training data for orange was slightly different,
no, interesting.
which immediately suggests that while, okay, the idea of an orange is pretty solid, those subtle differences in training could become much more important in, let's say, less obvious situations.
Definitely something to keep in the back of our minds then. Okay, now, the second and third possible outcomes, they both end up with this label, undefined label, right? Meaning the AI doesn't confidently recognize anything.
Correct.
But it seems there are two quite distinct reasons why this might happen. Can you break those down for us?
Sure. So the first way a sample gets an undefined label is when it's actually quite similar to something the AI has learned, but for some reason it doesn't quite trigger a confident or consistent match.
Right, so it's close but no cigar, kind of?
Exactly. Think of it like a near miss. The AI is sort of in the ballpark of what it knows,
Yeah.
but can't quite lock onto a specific category.
Okay. What's the other way a sample ends up like this with undefined label?
The second scenario is when the sample is just completely out of left field.
Like random noise.
Yeah, we're talking noisy data, maybe a mislabeled image, something that's just very different from anything the AI encountered during its training.
Right.
In this case, it also gets labeled undefined label. It's what you might call an out-of-distribution sample, really far from what it knows.
Okay, so two different paths leading to the same undefined label result. But the source material points out a key underlying cause for both of these no recognition outcomes. What's the core issue there?
Well, the fundamental reason for both scenarios is basically a mismatch between the training data the AI was exposed to and the characteristics of the test sample it's currently looking at.
So it hasn't seen something similar enough before.
Essentially, yeah. Undefined label often means the AI just hasn't seen something like this or similar enough in its training. When what the AI has learned doesn't align well with what it's seeing now, it struggles. It can't make a confident call.
That makes perfect sense. And the material also mentions some common signs, indicators that these mismatches might be happening. What should you, the listener, maybe be looking for?
Yeah, the two main indicators are first, inconsistent predictions, like when different AI models analyze the exact same sample and give different answers.
Okay.
And second, generally low confidence scores attached to whatever predictions are made. These are kind of red flags suggesting the AI is unsure or maybe the input data itself is problematic.
Right. Let's dive deeper into this whole no recognition area then, with some of the examples provided. The first one highlights a case of low confidence. What exactly occurred there?
Okay, so in this instance, a sample just didn't strongly resemble any of the patterns the models had been trained on,
Right.
which naturally led to low confidence in their predictions.
Yeah.
Now, Model A, remember, it was trained on fewer classes overall.
A simpler one, yeah.
It consistently predicted orange across its various tests, but always with a low average confidence score, which, triggered a review by a human expert.
Interesting that it kept saying orange even when it wasn't very sure. Why might that be?
Well, one thought is that Model A, having been exposed to a narrower range of categories during training, might have a sort of stronger prior belief in the concepts it does know, so it defaults to orange, even with low certainty.
Ah, okay. That contrasts with Model B then. What happened with Model B, the one trained on more categories?
So Model B actually incorrectly predicted sliced bread.
Wait, sliced bread?
Yeah, due to some visual similarities it apparently picked up on, and importantly, it also did so with low confidence.
Wow, sliced bread from an orange-related query. That's unexpected. What
Yeah.
visual cues could possibly lead to that?
It's hard to say exactly without seeing the image in the model's internals, but maybe texture, color patterns. But the key point is, this difference in how the models responded, even with low confidence, led to a crucial decision during the expert review.
Okay, tell us more about that review. What was the key takeaway?
Well, the expert accepted Model A's consistent, even though it's low confidence, orange prediction.
Okay.
However, Model B's incorrect sliced bread prediction, that was rejected.
Right.
And this really emphasizes that it's not just about how sure the AI seems, the confidence score, but also about how reliable and consistent the outcome is.
That's a really good point.
Yeah, even a prediction with low confidence can sometimes be useful if it consistently points in the generally right direction.
Consistency matters, even if the AI isn't shouting its answer from the rooftops. Okay, now, let's look at the noisy sample example. What happened there?
Right, this was a situation where a sample was found using the search term orange, but it turned out to be a color chart, just showing various shades of orange.
Ah, not an actual orange fruit.
Exactly, just colors. And this irrelevant, unclear information really seemed to confuse the AI models. All 9 versions of both Model A and Model B gave either low or inconsistent confidence scores.
Like when you do an image search and get those weird random results sometimes.
Precisely. Issues with irrelevant input are often a factor.
And what was the final decision on that one? No surprise, I guess.
Unsurprisingly, yeah, it was labeled as undefined label, and the expert review confirmed Model A's outcome as such. It just clearly demonstrates how much AI relies on meaningful visual information and really struggles when faced with something completely outside of what it expects.
Makes sense. Okay, next up, we have an example of a mislabeled sample. What went wrong in this case?
Okay, here, an image was labeled orange, but it actually showed a pair of shoes with an orange Nike logo on them.
So orange was present, but not the main subject.
Right, because the main part of the image, the shoes themselves, didn't match any category the models had been trained to recognize. Both Model A and Model B just failed to identify it. They both spat out undefined label.
And this really hammers home how crucial accurate labeling is when training these systems, doesn't it?
Absolutely. It's the foundation of what they learn. If the AI learns based on incorrect labels.
It's bound to make mistakes when it encounters the real thing later.
Exactly. It's like teaching someone the wrong name for an object. They'll keep getting it wrong because that's the connection they learned.
The AI learns that connection between the label and the visual features. If that connection is wrong during training, it will inevitably lead to errors during recognition.
Precisely.
Okay, now let's move on to a slightly different kind of problem. Inconsistent labels. Tell us about that scenario.
Yeah. This involved a single image sample that was apparently labeled in the training data as both car and vehicle.
Ah, overlapping terms. I can see how that might cause issues.
Right. This ambiguity caused problems when the models tried to classify it. Model A, which hadn't been trained on either of those specific labels, just predictably returned undefined label.
Makes sense. If it hasn't seen it, it won't recognize it.
Simple as that.
But what happened with Model B, the one that had been trained on both car and vehicle?
Well, Model B showed inconsistent predictions. Across several attempts, it labeled the sample as vehicle 8 times.
Okay, mostly vehicle.
But it also incorrectly identified it as car once, and apparently with low confidence that time. So this variation in the predictions clearly indicated confusion, likely arising from that dual labeling in the first place.
And how is this inconsistency resolved then?
Well, an expert review had to step in, and they finalized the label as vehicle car, basically acknowledging the inherent overlap and the potential for confusion.
So human oversight needed again.
Yeah, And it shows how vital it is to have clear and consistent labeling in the training data if you want to prevent these kinds of mixed signals and uncertain outcomes.
Okay, now here's where, for me, it gets really interesting. The case of parrots versus penguins.
Ah, yes.
Both models were trained to recognize the broad category of bird, but then they were tested on two very different types of birds. What were the results?
Exactly. The goal here was to see how well the models could generalize within a category, especially when faced with examples that varied quite a bit in how visually similar they were to the, let's say, typical training data.
Right. So parrots were considered visually quite similar to typical bird images.
That was the idea, yeah. Whereas penguins are, quite visually distinct, different shape, posture, environment often.
Definitely. Okay, so how did the models perform when shown images of parrots? The similar ones.
With the parrot samples, both models actually did a decent job of correctly identifying them as bird. However, Model A showed slightly better recognition accuracy, 73.3%, compared to Model B's 66.7%.
Okay. A was a bit better there. Any weird mistakes?
Interestingly, yes, Model A did misclassify a small percentage, about 3.3%, as jungle.
Huh, jungle.
Yeah,
That's a curious mistake. Maybe some of the parrot images in his training data also contain prominent jungle backgrounds.
that's a plausible theory. Background context can definitely influence these models.
Okay, now what about the penguins, the visually different ones? This is where I was particularly curious.
Right. The penguins being quite different from maybe more common bird examples, they proved to be more challenging for both models,
As you might expect.
as you might expect. However, surprisingly, Model B actually performed better in this case.
Really, B did better with the less typical example.
Yes, it correctly identified penguins as bird 57.1% of the time, compared to Model A's much lower accuracy of just 39.3%.
Wow, that is a surprise.
Yeah.
Pretty significant difference, too. I would have maybe guessed the more bird-like parrots would be easier for both. What might explain Model B's unexpected strength with the penguins?
Well, the key insight here, as the source material highlights, is that these AI models work by matching patterns.
Okay.
The closer a test sample is to the visual patterns it encountered during its training, generally the higher the chance of correct recognition. Parrots likely shared more visual characteristics with the general bird training data, things like, feathers, beaks, wings, in a certain configuration.
Than the very different-looking penguins.
Exactly. We'd probably see more features we instantly associate with bird in pictures of parrots than in pictures of penguins, which stand upright, don't really fly in the same way, live in icy places.
That makes intuitive sense. So what's the interpretation of why B did better with penguins, then?
Well, this leads to a really crucial insight. It seems Model A might perform better when dealing with patterns that are familiar and closely resemble its training data, like the parrots.
Okay, good with the familiar.
Right. On the other hand, Model B appears to handle cases that are less familiar and more visually distinct, like the penguins, with maybe a greater degree of flexibility or generalization.
Huh. So different models, maybe different architectures or training might have different strengths. One better at recognizing things similar to what it's seen, the other better at stretching to recognize novel variations.
That's exactly what it suggests. The divergent performance with parrots and penguins really offers this profound insight. The very design and training of an AI model can fundamentally shape its ability to generalize, favoring either familiarity or novelty.
That's fascinating. And it has significant implications for how we might choose or deploy these systems in different real-world scenarios, right?
Absolutely. And this also ties into the point made about how detailed the labeling is. The source mentions that if you train a model with more specific labels, say training it to recognize cockatoo instead of just the broader parrot.
It can become much more precise.
Exactly, it can learn finer distinctions. So instead of just recognizing a general bird, a more specifically trained model could potentially differentiate between a parrot, a penguin, and maybe a cockatoo if trained that way.
Which shows the ongoing refinement, the potential for improvement in AI capabilities through more detailed and, well, informative training data. So bringing this all together, then, it really just keeps underscoring that critical relationship between the data used to train these AI systems and how accurately they can recognize things out in the wild.
Precisely. When the test data aligns well with what the model has learned, it tends to perform well. Makes sense.
Yeah.
However, when there's a mismatch, whether that's due to noisy data, incorrect labels, inconsistent labels, or even just natural, sometimes significant variations within a category like birds, the model struggles.
And that leads to those low confidence scores or the incorrect classifications we've been discussing.
That's the pattern.
So, what does this all mean for you, the listener? I think understanding these fundamental principles helps you appreciate both the impressive capabilities, but also the potential limitations of these AI-driven recognition systems.
Right. The fact that a slightly different training set for something as simple as orange could still result in high confidence, or that a visual similarity to sliced bread could briefly confuse an AI trained on more categories.
Hmm.
It reveals the fascinating, sometimes counterintuitive ways these models learn and sometimes misinterpret information.
Yeah, and that penguin versus parrot example is just beautiful, I think. It illustrates that different AI designs might have different strengths, one excelling with the familiar, the other maybe handling the new and unexpected a bit better.
And the mention of more detailed labeling, it really opens up a whole avenue for how we can potentially make these systems even more accurate and useful down the line.
It definitely does. And this, I think, raises a really important question for you to consider. As AI becomes increasingly integrated into, well, almost everything in our lives, how do we ensure that the data used to train these systems is robust enough, representative enough to handle the sheer complexity and variability of the real world it's going to encounter?
Yeah, how do we make sure it's ready for the messiness of reality?
Exactly. It's definitely something to mull over.